Welcome, loud teachers and students. This is Learning is Not Quiet, Place Value Notes. We are going to talk today about why numbers are in the order that they're in and how that matters. We're also going to talk about different ways to conceptualize, visualize, and interact with these numbers. We always want to be mindful about our math, so let's take a deep breath in to begin and out. I want you to tell yourself that you are smart, capable, and strong, and you are going to do an awesome job with this concept today. So our number talk for today is 80 plus 16. Brief mention about number talks. This is just a place for us to work through different strategies to solve math problems. It's to make sure that we're building up our fluency, if you want the teacher word. So I want you to think. You can pause this video if you want to. You can respond on your worksheet. How could I add together 80 plus 16? What are all the different ways? Some ways that we could solve 80 plus 16 if you're totally lost are we could start at 80 and count up 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96. That's one way. We could count in our fingers. Another way might be that we show this with base 10 blocks and we add 8 tens plus 1 10, that's 9 tens, and then 6 ones, which makes 96. Another way we could do this is with the algorithm, where we stack them on top of each other. 0 plus 6 is 6, 8 plus 1 is 9. We could do this by separating 16 is also 10 plus 6. So we could add 80 plus 10 is 90, plus 6 is 96. Notice that all of the different ways that we're doing this, we still get that common answer or that same answer of 96. Let's start with some definitions. Place value is a word that we use a lot in math that means a digit has more or less value based on where it's found in a number. Basically, it just means that order matters when we're talking about math. Look at these numbers being all cute. So the 1 is saying to the 0, you make me feel 10 times stronger. And the 0 is saying, I'm nothing without you. Our next definition that we have here is digit, a number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 that can be by itself, but also can appear as part of a bigger number. And if we were to use that new vocabulary word in a sentence, multiply a one-digit number by 11, like 6 times 11, it would be 66. The number appears twice. Oh my god, I'm a math genius. Now that we're familiar with our vocabulary, it's time to become familiar with the numbers in this place value system. The first is ones, which are worth just the digit value. So this is worth 8, also shown by those tiny little squares. Next, let's welcome the tens to the place value system. As you see, we represent these tens with 10 of those little ones put together in a stick. And this makes 6 of those tens is 60, and that's how we get this number 60 plus 8, 68. Next, we have the hundreds. Hundreds are worth 100 times the digit's value. So this 3 digit here is not just worth 3, it's worth 300. It's also represented by those giant flat squares that we use in our base 10 blocks. Next, we have the thousands. 1,000 is worth 1,000 times its digit's value and is often represented by those giant cubey things. So now let's get crazy with it because there's actually an infinite number of place value. So we have ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, and billions. The numbers get bigger and bigger and bigger and bigger and bigger, multiplying by 10 each time you move to the left. Now, loud teachers and students, it's time for a chant about place value. We have ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 10 billions, 100 billions. Now with a puppy. Don't be scared, no one's watching. We have ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions. And you'll see I like using chants like that because it helps us recognize the patterns that we have with numbers. And that pattern is really important to notice. As much as my puppy doesn't like it, there's no reason to be embarrassed about singing or chanting because you're probably either socially distanced at school or by yourself at home, so sing along. And some more vocabulary before we dive even deeper into this concept. I'm writing out a number for us here. We know that a period is separated by a comma, and a period is just a fancy name in math for 3 numbers in a really, really big number. And then remember, each digit is just 1, 2, 3, 4, 5, 6, 7, 8, 9 by itself, like we see here. And of course, things are false. Let's look at one type of example problem, and that would be to identify the value, or how much one digit is worth by itself. So let's take a look at this 8 here. We're trying to figure out the value of this 8 in the number. So let's count ones, tens, hundreds, thousands, 10,000s. So our 8 is worth 8 10,000s or 80,000s. Let's do one more problem like this. Let's say we're not trying to find the value of the 8, but instead we're trying to find the value of this 4. So let's get ready to count again. We have ones, tens, hundreds, thousands, 10,000s, 100,000s, millions. So we have 4 million. We can show numbers in a couple of different ways. The first is standard. This means that the number is written with just digits. In this case, 2,304 is written 2,304. It's basically the way we usually talk and think about numbers. The second is written. Written means the number is written with, wait for it, words. What? In this case, it's written TWO 2,304. Note there is no and. If you use and, you're telling me that there is a decimal there, so get that out of your head. The third way is expanded, which also is just like it sounds. Each digit is separated, showing how much it's worth. So in this case, 2,304 is shown as 2,000 plus 300 plus 4. Expanded can also be shown with powers of 10, showing how much more each of the digits is worth as you move to the left. So in this case, it's 2 times 10 to the third power, plus 3 times 10 to the second power, plus 4. Let's see how this works on the whiteboard. All right, so first we have standard form, and like I was saying before, this is the way we normally think about numbers. You see I've written a simple number, 1, 2, 3, 4. In written, we're writing it out with words. So that's 1,234. Notice how I don't use and, because that would mean decimals. Expanded is where we separate those digits. You'll see me often write in standard form above so that I can cross off the digits as I record them. Another way to show expanded form is to multiply each of the digits times their place values. This would look like 1 times 1,000 plus 2 times 100 plus 3 times 10 plus 4. Finally, we can do this as a powers of 10 situation. We count up the number of zeros like you see me doing here, and that becomes the power. So we multiply that front digit times 10 to the power, and that power represents the place or the number of zeros that fall behind it. So 1 times 10 to the third power plus 2 times 10 to the second power plus 3 times 10 to the first power plus 4. Notice how those powers of 10 represent the number of zeros. We'll talk more about this in a future video. Now it is time for an activity. Yeah! What we're doing is we're going to take what we've been talking about and apply it with a kind of game. Now we're going to be playing this game by ourselves, whether you're at home or at school socially distanced. You're going to have 10 sticky notes in front of you, each with a separate digit written on it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. If you don't have Post-it notes, you can take a sheet of paper, rip it up, write 1, 2, 3, 4, 5, 6, 7, 8, 9, and the main thing here is you want to be able to move them around. So if you have playing cards, whatever it may be, you just want to be able to move the digits around to form different numbers. During this game/activity, I'm going to show a picture of either base 10 blocks, maybe something in written form or expanded form. What you need to do is you need to look at that number or that model, and you need to form that number in standard form using your digits in sticky notes. So you're going to take your sticky notes, you're going to rearrange them so that they form the right number. After you've solved, you can push play, or you can keep watching the video if you're super fast and check to see if you got that answer right. Are you ready? Let's begin. So this is our first question. Take a look at these different base 10 blocks and try to rearrange your digit cards to make that number. And here it is. The answer to that question is 1,254. Notice I'm not saying that word and. All right, so let's keep going. Here's our next model. Take those post-it notes, rearrange, and the answer is 3,278. I'm going to go quiet for a little bit so you can work on these by yourself. Thank you so much, parents, teachers, and students, for visiting this channel and watching this video with me. Teachers and parents, for the worksheet that goes with this, it is available on teacherspayteachers.com. Search for Learning is Not Quiet. If you want to support this video and other videos like it and free education to students during this difficult time, please visit my Patreon page, search for Learning is Not Quiet. Links for both are included in the description. Bye!